The theater. A place we gather to share deeply human experiences. A place that challenges us to think, invites us to love, and shows us that we are bigger than ourselves.
The performance you're about to see is based on real events in the lives of Brad and Sara Eastman, a young couple whose story begins with a blind date. And that story takes us to a place that's hard to reach, but is responsible for much of who we are, the source of our power to speak, reason, imagine, the source of all the drama of our lives. That place is the human brain. Generations of our ancestors devoted decades to mapping the universe we can see. But only recently did scientific ingenuity map the universe within us, the human genome. Inside Washington University in St. Louis, a leading medical research institution, scientists apply their knowledge of genetics and neuroimaging to continue making discoveries in the vast neural networks that make up our minds. Albert Kim, once a Chinese literature major at Harvard, now stares down the most deviant of all cells, cancerous brain tumors. Eric Leuthardt, author of sci-fi thrillers in his spare time, is rewriting patient outcomes in once damaged systems. Both are neurosurgeons at Barnes-Jewish Hospital. Their resolve to understand just how our brains operate is translating into new knowledge and advanced techniques that are saving lives.
Now imagine, what if your doctor wrote a play? A story that connects medical science to love, grit, tragedy. What if he starred in it?
Well, that's exactly what Drs. Kim and Leuthardt did before an audience of 1,400 people in this theater.
Do you think he's going to make it?
I don't know. It's going to be a very hard case.
He's young, isn't he? What's his name again?
Brad. And just married.
You know, it's amazing how in a moment your life can change.
But it's really all those moments that come before that make the life in the first place.
That's right, all mediated by that stuff between our ears, our brains. It's interesting how those moments shape us and how we shape those moments.
And when you think about it, it's all about connections. Neurons talk to neurons, and those neurons form networks. And those networks form the brain.
And the brain makes the human.
And a brain isn't a brain without another human.
It all starts with that first connection.
It's a classic love story. Brad and Sara get married, and like so many young couples in love, they move into their first home and begin building a future together. Only things were going on behind the scenes in a place neither of them could see. Something was happening in Brad's brain that would change their lives.
Hello?
Hello, Sara. This is Dr. Leuthardt from Barnes-Jewish Hospital. Earlier today, Brad was with his coworker. He suddenly stopped talking and then became unconscious. I'm worried he had a seizure.
Oh, God. This morning? Why didn't anyone call me earlier?
They tried. It went right to voicemail. And then they called 911.
Where is he now?
He's going to be arriving shortly. He's in an ambulance, but he's stable. Has he ever had a seizure before?
No. He hasn't had any medical problems. I don't even remember the last time he went to see a doctor. I mean, he runs triathlons. He's healthy. What does that mean that he's had a seizure?
A seizure is an abnormal activation of the brain where the neurons fire too much. And it can involve different parts of the brain. So, for instance, if it involves the motor cortex, then the opposite side of the body will jerk and spasm abnormally. If it involves visual cortex in the back of the brain, then that person will experience abnormal visions, such as seeing spots or distortions of vision. Now, occasionally, those seizures, that abnormal activation will spread and involve the entire brain, and that leads to the entire body convulsing and the person losing consciousness.
What causes that? And is he still in danger?
At this point, Sara, I don't know. We're going to have to run some more tests, but for right now, he's stable.
What should I do?
Why don't you get here as quickly and safely as possible, and we're going to go from there.
I'm on my way.
This is Brad's MRI, I'm guessing. It's something in the left frontal lobe. It's very suspicious for a tumor.
Cancer in general is kind of funny, and it's a strange aspect of our human biology.
How do you mean?
Well, cancer in a lot of ways is a conspiracy of your own cells against your body.
Ah, I see where you're going with this. You're telling me the cell of origin of the cancer may be a neural progenitor, incurs genetic mutations on EGF receptor,
Whoa,
P10,
whoa. Double nerd check. Okay, stop. Why don't you tell us how you think brain tumors form, or tumors in general?
Good idea. Let's take human skin. You have skin cells which divide in a controlled manner and occasionally are damaged by the sun. Now, sometimes when a cell is too injured, it dies and it's removed from the body.
So what you're telling me is that essentially each cell in our body has a genetic playbook that it knows that when it's injured, it'll die and go away.
That's right, but with skin cancer, a cell basically injured by UV light accumulates genetic mutations. That changes the playbook so the cell doesn't die anymore like it should, but instead grows in an uncontrolled fashion. For brain tumors like Brad's, it's not UV light, but some unknown cause that leads to unrestricted growth and invasion.
Standard cancer therapies like radiation and chemotherapy kill these rapidly growing cells, and it's saving lives. So why then does disease return? Dr. Kim is trying to understand, not on stage, but in real life, at his lab for molecular neuro-oncology.
It's not just one kind of cancer cell. This patient will have, let's say, the same type of brain cancer as this other patient. Those brain cancers are still very different. So they're different subtypes of brain cancers, even with brain cancers of the same name. So there are a lot of different kinds of cancer cells, even in one person's tumor. And I study a really angry and quite difficult population of cancer cells called cancer stem cells.
These cells resist standard therapies because of their stem-like features. They can make more of themselves and other rapidly growing cells. Even after successful surgery, if just one cancer cell remains, a tumor can recur.
It's not just understanding what these cells look like or how they act. If we can understand what they're vulnerable to, we can design specific cancer stem cell targeted drugs or therapies. It would prevent the tumor from coming back.
Dr. Kim's resolve to get answers in his lab is breaking down barriers between medical research and care.
The tissue that we get from my operations, from my colleagues' operations, the cells that we're looking at are human brain tumor cells that we get from patients after their consent. It makes a difference for me, emotionally. It reminds me that what we're doing this for is a very human reason. As bad as the disease is, there is this optimism that I feel when I study these cells. The answer's in there somewhere, And if we could just unlock that answer, how much of a benefit could that be to Brad and also for people with conditions like Brad's tumor? There's nothing that can really speak to the fear and uncertainty that comes along with a brain tumor diagnosis.
Brad and Sarah's sympathetic nervous system.
That's right, the sympathetic nervous system, the most primitive system in our entire brain and spine. I think it's responsible for that fight or flight response.
Indeed, it's what's causing their hearts to race right now. They're starting to breathe heavy, their pupils are dilating.
Unfortunately, what was geared to protect us against the saber-toothed tiger makes us a bumbling fool on a first date.
You must be...
I'm sorry. You first.
No, go ahead, please.
You must be Sara.
I am. Brad?
Yes, I'm Brad.
We found each other.
It's hard to be charming when every part of your body is telling you to run like hell.
Indeed, what worked great on the savannah 60,000 years ago in a coffee shop, it's a disaster.
Shall we sit? Here?
Okay. Oh,
Yes, I think we're about to see the next step in this little courtship ritual, the mating ritual.
The mating ritual. So notice the male is assuming the typical mating posture. The female is deciding whether to accept his advances. This courtship is a very complex interplay.
Let's examine the male's first mating strategy. I believe they call this the tactic of, I'm too cool.
And just like a peacock ruffling his feathers or a rooster strutting, his nervous system is amping itself up for a dramatic display.
So, your profile says you're into British comedy.
Yeah, pretty much. I love dry humor. What about you?
Oh, I like to think I relish the truly sophisticated pen. You know, political satire that makes fun of every mundane cliche.
Sure, you mean like Woody Allen or Stephen Colbert?
No, smart, edgier stuff. Like Adam Sandler.
Right.
You know, commentary that makes you dig down and think. Like Will Ferrell, for example.
Ouch.
This is not going well, but never underestimate the power of the male mating drive.
That's true. Dudes never give up.
I'm joking. I'm joking. I'm sorry. That was just my weird attempt to try to break the ice.
Thank God. I am so gullible sometimes.
No. I'm just a really good actor.
You really terrified me there for a moment.
I'm so sorry. You have a really nice laugh. Just makes me smile.
Thanks.
2 pumpkin lattes?
Perfect, Brad. My fave.
Did you see that?
Yup, absolutely.
The universal sign of attraction, the female hair flip.
But what makes that connection? What triggers that?
A magic little molecule called dopamine. Basically a neurotransmitter that's mediated in the brain that governs pleasure. And whether it be those first moments of attraction, whether it be your home team hitting it out of the park, or when your favorite band is really killing it.
You know, it's these same dopamine signaling pathways that are actually hijacked by the brain in human addiction, like gambling, when the slot machines hit 777s, or drug abuse, or even cigarettes.
Now, for Brad and Sara, even though their brain is producing one of the most intoxicating things our brain can do, there's more to it than just pleasure.
No, that's right. I mean, they have to make a more complex decision. They're thinking things like, do I want to spend part of my life with this person? Attraction just opens the door to that question.
So,
Well,
I
I really enjoyed this.
me too.
Maybe,
Dinner, perhaps.
yes, I'd like that.
So would I. Well, it was a really nice date. I'll see you soon.
Soon, yes.
Wait, so should I
So
call?
I'll
I'll call you.
okay.
Bye.
Bye.
Hey.
It looks like Brad and Sara have some potential. It's a reminder that biology, our genetic history, has real effects on the day-to-day moments of our lives. From the cavemen days of sitting around the fire, to ancient Greek theater, to reality TV, an essential part of being human is the need to express ourselves through storytelling.
Dr. Kim, Dr. Leuthardt, I know that you're both interested in making neuroscience more accessible. Is that why you created a play rather than a lecture?
That's a great question. I think there's something very intimate, very engaging, very personal about having a theater-level type of production for presenting this kind of information. That was one of the reasons Dr. Leuthardt and I wanted to bring this sort of knowledge in that setting.
And interestingly, it also links up to our neuroscience. We are built to be social creatures, and I think once you put something into a context where you can be part of that conversation, you receive the information so much more deeply. So for instance, it's the difference why sometimes you fall asleep at a lecture, but if people are gossiping about something, you're interested to listen.
In terms of the science, as a scientist, I think we have a sort of a responsibility to convey what we discover in an accurate and a clear way to the public.
We're not just limited to medical students. We're not just limited to trainees. I think that we have an obligation to society and the public at large.
So that's part of the calling, I believe, also for
absolutely.
brain work.
That's right.
It's sort of a scientific calling to
Yeah.
educate what we know about the brain.
But I'm sure that when you were in medical school, you weren't thinking about being up on stage, remembering your lines and hitting marks.
We talked about that a fair bit. You know, when we were with the actors, I think we all had this feeling like, we never expected to be with you guys, and the actors were like, well, we never expected to be acting with neurosurgeons, and so...
I'm probably more comfortable doing a surgery than being on stage. And,
No question.
And so we had to learn really quick how to be comfortable on stage, and that was quite foreign.
You know, it really took us like a week to where we were exhausted. You know, when learning our lines, like
Right.
that was, you know, that was the most tiring. We really thought like surgery is much easier than doing this.
That's right. Or positioning our bodies a certain way in relation to the light or the stage. And
There was neuroscience at work. Learning was happening, and it was exhausting.
Human behavior is such a layer cake of different physiologies and drives.
Yeah, I know what you mean. Reflexes, pleasure, and fear at the bottom,
Emotions in the middle.
and higher cognitive functions and willpower on top. But our brain enables to do far more than just react. Didn't you tell me that Brad's an athlete?
Yeah, he just actually ran a triathlon.
Triathlon. Now that is just the perfect example of how the many layers of brain just does things.
All right, breathe, man. Sarah's watching. You are doing this for her, too. Because you are a lean, mean triathlon machine.
You know, when you think about it, the way we do things, the way we interact with the world, it really all comes down to the fact that some neurons in our brain control some muscles in our body.
I mean, on the simplest level, our brains make our bodies move. Different parts of a thin strip of brain called motor cortex control different groups of muscles in our body. One part for the face, one part for the arm, and one part for the leg. Each segment of that thin motor strip responsible for a body part on the opposite side of our body.
No, but Albert, we're not just flopping our arms around like we were babies. We're actually able to do complex movements.
You mean like a bicycle or something like that?
Exactly.
Yeah, no, absolutely. In fact, there's a part of the brain not for the commands to move, but for the fine coordination of those movements called the cerebellum, or little brain, which allows us to do things that are, I don't know, almost superhuman. Whether it's as a ballet dancer, a track star, or as a martial artist, our little brain or cerebellum orchestrates these masterful symphonies of fluid movement.
That is so awesome. And what's amazing is that we can do things that push us beyond our bodies. Like, here he comes. He's getting ready to run the marathon, the final leg of his triathlon.
Uh-oh. Looks like he's hitting the wall.
His brain and body are screaming for oxygen, his vision's coning down, his limbs are flopping around.
You know, just like an iPhone has an app for that, there are parts of his brain for just this moment, that willfulness that pushes us beyond our bodies, pushes us beyond our environment.
And that's the frontal lobes. That's the part of the brain involved in complex decision-making, attention, the ability to plan beyond the here and now.
And not only plan, I mean, anyone can plan to be in a race. What about persevere? Here comes Brad.
Scientists call that grit. That is that unique human capacity to stick with things, to see them through, all mediated by a ring-like structure in our brain called the cingulate gyrus. It gives us that ability to push, to do exceptional things. The ability, such as scientists, artists, soldiers, sometimes alone, sometimes in groups, to go beyond what's possible. Now, sometimes you have visionaries and leaders who don't just go beyond what's possible for themselves, but make it different for the entire world.
People are probably wondering here, do I have one of these? Do I have a cingulate gyrus?
Absolutely.
But not everyone's an Einstein or JFK.
But Albert, they all have the potential to be.
An inborn potential governed by our genes.
Albert, every part of our brain is like a muscle that can be trained to high performance.
I think our brains are hardwired by genes.
I'm not buying it.
Brad, you won!
Oh God, everything hurts. Oh, but it's great.
You did it!
Oh, I knew I could.
I knew you could too.
I want to hear you say it.
You won, Brad!
Yes.
I'm so proud of you, Brad.
That last week, when things got tough, you were there to push me through.
It didn't take much.
No, your timing. You trusted me. I love that about you.
Who's your biggest fan, mister?
You are. Come here.
Come on, they want to take your picture and give you a trophy.
Oh.